So the next one's R3 to R7. So 3, 4, 5, 6, 7, but not 8. And the next one's a 103, which are 10K, and there's 3 of them. This film that holds these in is so thin, feels like you're not touching anything. There we go. 1, 2, 3, there they are. These really are tiny. And those are the wrong resistors, because there's 3 of them and I need 5. Maybe they're capacitors then. 100 nanofarad. Okay, so that's C2, 4 and 5. 2, 4. And C5. Better to find out that you're wrong before you start soldering them. Oh, the fun you have when you wear spectacles. It's really hard to focus. Oops. Really hard to focus on things this small. Patience is everything. I'm not actually applying any pressure when I waggle it. I'm just literally doing that, waggling it, to ensure it's soldered properly. Because if these go flying off, I'll never find them again. And for components this small, ideally you only want to have the iron on for 2 seconds or 3 at the most. But they heat up so fast. When these are being done commercially, they'll be put onto the board, actually glued onto the board by a machine. Then they'll go into a reflow tank, and although it's full of molten solder, it would literally flow across a tank of molten solder. It's moving quite quickly, and the solder is at such a regulated temperature that it won't overheat. It really is only a couple of degrees higher than you absolutely need. And they also pump ultrasound into the solder to keep it fluid instead of using tons of flux. And that's how, when you buy commercial electronics, they are absolutely brilliantly done to such a high standard. Let's see if we can find the 5 resistors now. 6 resistors. So 3, 4, 5, 6, 7. Now I need 5 resistors. Wonder if they supplied 1 extra. So let's see what the other components are. R8 is a 2K2 and there's only 1 of them. And I can't see a single resistor. Yeah, keep the debris away from the components. C4 and 5. C2. So we've just done those. Oh God, there's 3 of those as well. Well, that's going to be interesting. Now then, I've got an odd number of components left, because I need 5 103 resistors, and I haven't got a clue what those are, because there weren't 3 of anything, and I keep trying to read the number on them. But even through a pair of spectacles and a magnifying glass. Hey, I've got an idea. Let's put the test meter on it. Why didn't I think of that before? Okay, cheap and nasty test meter. But still reasonably accurate. So if we're really lucky, these will measure 10k. If we're unlucky, it'll fly off the bench, never to be seen again. That's not measuring 10k. It's measuring 1 megohm. Which means that the other ones are probably wrong. So R1 and R2 should measure 1 megohm. This is something I should have done prior to putting them on, but... Right, so that's not bloody 1 megohm. It's 2k. So they've completely flummoxed me here with the wrong values. So these are going to have to come off and those are going to go on. What they've basically done is they've given me too many of each component. So R8, R1 and 2 should be 1 megohm. Those are the 1 megohms. These are 2k, sorry. So this, one of these needs to go in R8, the position for R8, which is up here. And then 2 of these 3 need to go into those positions. It's a voyage into the unknown. And again, we have to be careful because the heat will damage the components if we're not careful. This solder braid does, desoldering braid, not soldering braid, desoldering braid does contain flux. And as you can see, it works. Can you see that? Yes, you can see that. To remove them. Right, here's where it gets interesting. Oh, You little beast, you came out perfectly. So that one is going there, that's a 1 meg. I'll double check these in a minute. I'm putting more solder onto that one than I'm taking off. Unlucky. One or two things happens doing this sort of work. You either develop the patience of a saint, or you just go completely manic and destroy everything around you. It reminds me of the happy hours I used to have typing in code from computer magazines just to find out that it didn't work. Right. Let's check that resistance again. So this is going in R8. Well, let's see which one is which. That's the 2K. So that 2K is going in R8. In R8. It's the very end one. I will have to pause for breaks because this camcorder only has half an hour battery life, or 40 minutes. I haven't yet bought the bigger battery for it. And out of my choice of home cameras, this one does the best job, even though I'm lighting this up. Stay there, little components. This one doesn't matter, that can go over there. Just trying to make sure I'm in shot. Ooh, that felt okay. I'm literally doing this by feel as much as anything because I can't see a thing. Which is another reason why I didn't go back into electronics last time I changed jobs. I did a wiring test for, worked in TV and lighting, electronic lighting components for quite a few years, and then I stopped doing that and went into computers in the 90s. And a few years ago I had some career issues and I decided to have a change and go back into electronics. And the wiring test that they gave me was for a video camera to go down pipelines to inspect for blockages. The video camera was that size, and I turned it over and there were 46 wires went into the back of it. And the guy was giving me this trade test. He was very happy with my previous career and all the test work I'd done and design work. And he says, "There's the trade test." And I said, "No." He said, "What do you mean, no? You haven't even attempted it." I said, "I can't even see those wires, let alone solder them and strip them. Forget about it." So that's why I'm struggling a bit on this. Younger people may have better eyesight and be quite content doing it. So we now need these two 1 mega ohm resistors to go in R1 and R2. And we have too many as usual. So let's test these, confirm the 1 mega ohm. That one isn't measuring anything. That's measuring 1 mega ohm. That's measuring 1 mega ohm. That one may have been destroyed in the fire. The exuberant heating of it. So these are R1 and R2. Yeah, and I've already put solder on those. When I used to do this for a living, I used to have one of those big watchmakers magnifying glasses. The company actually provided them, which was great. And it was illuminated as well. But then again, you weren't trying to video it while you were doing it, which makes it 10 times, literally everything is 10 times harder while you're trying to video it. That's not an excuse, it's an absolute fact. You try doing this. This camera is about 14 inches from what I'm working on, and it's quite hard to see past it. Oh, that one's a little bit skew with, but because they're so small, I'm really not going to try and correct alignment issues. If you can see that. I won't know until I look at the footage. I'm going to have a look at it. Yeah, that'll do. Not perfect. Right, I think our one needs a bit more solder. I know that flowed in then, I don't know if you saw it on the camera, but it actually sucked the solder underneath. Right, so we've got, I need to mark these off on the sheet ideally. So we've got that one, so this R3 to R7 are 10Ks, and that are 5 of them, and as they've supplied 6, I'm going to stick my neck out and say that that's probably the right one. But this time, guess what we're going to do? I'm going to measure the flipping thing first. If you can hear some background noise, it's just some kids playing outside, they're not my kids. Can't really tell them to shut up, I'm videoing. Are these 10K? Marked 103. I can't read it. Oh, sorry, you can't see the meter. Can you see the meter? No, you can't. There we go. 10K. 10K. So those are definitely the 10Ks. And these are R3 to 8. And I haven't got them all out yet, just to reduce the chances of them disappearing. Sorry, R3 to R7, we've already done R8. Oh joy. The sound of concentration.